Okay, so in these kind of questions, you can find generic forms and you can apply, ideas, but don't get into that much. I mean, CAT is not testing all of that. Just use basic ideas. You'll always find patterns. You'll always find similar ideas. Until unless there is something which you observe which simplifies the problem a bit, do not try to apply any theorems or anything in these kind of cases. Just apply basic principle. So just read the constraints properly, because that is more important. So number of solutions to this equation where x, y, z are positive integers, and these are the limitations, right? So let me just write this down, because y and z have the same parity in terms of this thing, the sign of it. So I'll just write this as something like this. I hope this is simple enough to understand. Now, the thing is, I'm going to take the cases on X, because think about it. I mean, X is not helping us too much, right? Because if X is 40, I mean, X can first of all go only up to something like 27, right? Because Y and Z have to be positive integers, so they cannot be less than 1 each. So even if you take 1 plus 1, so this has to be 27, right? So X, first of all, has a very limited number of cases. And because of that disparity in the sign with X and Y and Z, so Y and Z have the same sign. So treat Y and Z separately and X separately. So just take the cases on X. So let me rewrite the cases here. I'm going to use this constraint. So I'm going to take the cases on X, and then I'm going to count the number of solutions for Y plus Z. So I'm going to write Y plus Z values here and count the number of solutions for Y and Z. That's it. So this is the idea that I'm going to use. So let's do this. So it's a very simple one. Trust me on it. Just let's look at it. You'll understand what I'm doing. First of all, start with the uppermost limit. So X being 40. So if X is 40, then Y plus Z has to be 15, right? Now, please understand, neither of Y or Z can exceed 12. So the values of Y and Z will range from 3, 12 to 12, 3, isn't it? Now, in these kind of cases, what I typically do is I'll count any one of them. So for Y, for example, so Y can range from 3 to 12, right? So that's a total of 15 solutions. What did I say? 3 to 12. 3 to 12, that is a total of 10 solutions, right? Difference plus 1 always. Don't count it as 9 solutions. So 3 to 12, that's 10 numbers, right? So there is a total of 10 solutions here. Now coming to the next bit, let's consider X as 39. Now we're not going to do it all brute force. You'll understand till what point I'm focusing on in a while. Just be patient in the first few cases. So if X is 39, then Y plus Z has to be 14. Again, you have that limitation of Y and Z to be up to 12 only. So I'm counting in terms of Y again. So Y could be anything from 2 to 12, right? See, y cannot be less than 2, because if Y is less than 2, then Z has to be 13 or 14. Y0 anyhow not possible. But then if Y is 1, then Z has to be 13, which is not possible. So Y can range from 2 to 12. So that's like 11 solutions, right? Now let's take the next one. Now this is the most important point. So if I consider X as 38. Now if X is 38, now you'll notice that Y plus Z is 13. So in this case, this is the first case where Y can be 1. Now, what is the importance of that? You'll understand this now. See, Y is 1, then Y can go up to 12, right? There's a symmetry between Y and Z. So accordingly, Z will also have that many solutions. So don't worry about Z. So Y have 1 to 12. So that's a total total number of solutions being equal to 12. Now check this out. If I consider X as 37, then Y plus Z is 12, right? Now in this case, what will happen is Y will stick with the minimum possibility as 1. The upper limit will reduce by 1, because if Y plus Z is 12, suppose I consider Z is equal to 1, then Y can be 12, right? Now Z cannot be less than 1, because this is a positive integer. So Y can range only from 1 to 11. So if Y is ranging from 1 to 11, that's a reduction of one solution from the previous case, isn't it? So this pattern is what will happen in the following solution. So let's say X is 36. In that case, y plus z is 11. So y will range from 1 to 10. I hope you're getting the idea. So again, I hope you can see there's a reduction of 1. Now forget about the value of x or how many reduction it is. If it is reducing by 1, there will be a point at which the number of solution will hit 1, right? There is one solution. We actually have discussed that for x equal to 27. Y plus z will be 2, and that will have just one solution, 1 plus 1. But we don't need to worry about these things. Now, what I know is because this side is continuously reducing by 1, there will be a stage when this will hit on 1. So because that will happen, what I can say is the number of solutions that we have is, first of all, consider these two. Don't forget these two. So you have 10 plus 11. And the other side, you have 12 plus 11 plus 10 plus 9. This goes up to 2 plus 1. Somewhere it's hit 2, somewhere it hits 1. Now, I hope you know this summation. So 1 to 12, that's a summation of 12 into 13 by 2, and plus this 21. So this is giving us 78 plus 21. So that's a total of 99 solution. That's the answer for this question. So this is the simplest way you can solve using the basics. Don't try to get into approaches and formulas and stuff. You would overcomplicate it and get confused in between. So it's better to take cases. There will always be a pattern, something or the other. It's not mandatory that the pattern will always be a reduction of one case. It could be a reduction of 2 cases, 3 cases, doesn't matter. It depends on the context. But then you'll always find patterns in these kind of questions when it comes to CAT. So that's it for this question. This will take some time to do whenever you have a question like this. So I would say somewhere around 2 to 2.5 minutes is an ideal time to solve this question. If you identify these kind of patterns quickly, then you can figure it out. On the other hand, if you try to use some approaches and stuff, so not only your accuracy might hit, it might also happen that you make a mistake in get a mistake in somewhere and then get into the trap, and just keep revolving around that question, and you waste too much time on this question. It might happen. So that is why I'm suggesting not to use any theorems and stuff. Just use it with a basic understanding. So that is sufficient for these type of exams. So that's it for this question. I hope that was understood. Thank you.